Everyone, welcome back to my YouTube channel. This is the first video of my new series, Daily LeetCode Challenge. So today's Daily LeetCode Challenge is remove nth node from end of list. This seems to be a easy one. It's rated as medium. So we're given a head of the linked list and we need to remove the nth node from the end of the list and return its head. So in this case 1, 2, 3, 4, 5, we need to remove the second node from the end. So 3 will now point to 5. So like this question can have multiple approaches. Like if you take one would be um, first we can find the length of the list. Finding the length would be pretty easy. We can just go over all of the nodes until we find the null, and this way we can find the length of the list or the length of all the nodes. And then once we are done with it, suppose here we'll find it to be 5, and we need to remove the second node from the end of the list. So now number of nodes we need to traverse from start would be 5 minus 2, that is 3. So we can go from 1 to 2, 2 to 3, and then from 3 we can directly point to the last one. Right, so this is one approach which is quite easy. We can follow this as well. But there's one more approach that I would like to take from here. Like we'll have one pointer. Suppose we have one pointer slow or s, which is at 1 initially at the head of the linked list. So we'll just make it move to the next pointer n times. So n is given as 2 here. So our first time it will go to 2, right? Now next time it will go to 3. Nice. So we came to 3 now. So now what we can do is we can start one more pointer from here, and that will be our one more pointer, suppose A. Now this pointer or P, this pointer will again start from the very end, from the very beginning, from the head. Now we'll traverse both of these one by one. Suppose P comes to 2, now S should go to 4. Now P comes to 3, S should go to 5. Now we should stop when our previous pointer or the S pointer reaches to the last node where the next node is null. So now we have stopped there. Now we can directly, what we can do, we can simply do like p dot next is equal to p dot next dot next. Simply we have got rid of this second last element. Like that we need not find the length of the list this way. And there's one edge case in this approach, which would be when n is equal to length of the list. So when n is equal to length of the list, suppose n is equal to 5. So we'll start it again from 1, 2, 3, 4 and 5. So we'll start our pointer from S. It comes to 2, 1. It comes to 2, one jump it has taken. Now the second jump, third jump, fourth jump, and now the fifth jump. Now on the fifth jump it has reached a null. So we can just make one check if our S has reached a null at the very beginning only. So we need not take this P pointer, another pointer which should be doing our job. That means we need to get rid of the very first. So we can simply return head.next. This was the edge case. So let's just code this out. Let's just take list node. Let's name it as fast, our very first one. So we'll move it. Now we'll check if fast is equal to null. We can return fast dot head dot next. Otherwise we'll take one more pointer slow, which is head now, while fast dot next is not equal to null, because fast is definitely not null. As you can see, we have to stop where the next one is null. So we need to stop at the last element. So now what we can directly do is fast would be traversed by 1 and slow would be traversed by 1. Now once we reach, Now our slow, that is p, is now at 3, so we need to do this. We need to update its next. So we can just do slow.next equal to slow.next.next, and we can simply return head. Let's try to run it. Seems good. Yeah, perfect. Thanks a lot for watching. Let me know if there's any problem in the comments.